Okay, so how to actually go from degrees to radians and back again. I want to kind of go back, this goes all the way back to middle school, so I think you haven't heard this term in a while. You really need to know it anyway. It's called a unit change factor. I need to remember my own tablet. Unit change factor, and unit means one. So you're trying to change from one type of unit to another, right? So a unit is, say, an inch, a mile, a second, whatever it is. And to change the units, the word unit kind of plays a dual role in this title. You need to change from one unit to another, but you can also really only multiply by one. So if I were to say to you, I ran 20 yards, and I asked you how many feet is that, you would immediately multiply 20 by 3 because there are 3 feet per yard. And you'd say, oh, 20 yards is 60 feet. If I asked you how many inches that is, you'd go ahead and you might take a few more seconds than the last time, but you'd multiply that 60 feet by 12 inches because you know each foot has 12 inches. So here's what you're really kind of doing. So I take my 20 yards, and I want to get rid of those yards in the first pass, and I want to get feet. So I want to end up with feet, and I want to cancel the yards. Okay, so these will cancel because this is kind of like over 1. So I get to cancel the yards. I'll have feet up here, but I can only multiply by 1. 1 yard is equal to 3 feet. So if I multiply by 3 feet over 1 yard, then I've just multiplied by 1. And I get to cancel those, and that's where I get my 60 feet. This is a unit change factor. If I then wanted to do inches, now the thing I want to get rid of is feet, and the thing I want to end up with is inches. I need these to cancel, but I can only still multiply by 1. 1 foot is 12 inches, so I can multiply by this. The feet cancel, and I end up with inches being the only unit in town. So I've multiplied the 20 by the 3 by the 12. As I said, you would have done this automatically, no question. Sometimes it's not things that you know as well. And sometimes if I were to ask you, say, to translate from years to seconds, you'd probably in some point in that process make an error. If I asked you to go from seconds to years, almost guaranteed you'd sometime make an error. If you always write it out as a unit change factor, then you're not likely to make the error. So in the situation of degrees versus radians, what we know is this: 2 pi radians, this is radians, not radius, equals 360 degrees. So 360 degrees over, oh, this thing is so nuts, 2 pi radians is 1. This is also 180 degrees over pi radians because why work harder than we have to, right? There's a 2 in both cases. Also, if I had, say, 433 inches and I asked you how many feet that is, you'd divide it by 12, because what you'd really be doing is saying, I want feet, here's 1 foot, is 12 inches, and that's the way I get to cancel inches. Similarly, I could multiply by pi radians over 180 degrees. And I'm really just multiplying by 1. And then I get to cancel out whatever unit I wanted to cancel out. So if you're asked to, say, write pi over 9 in degrees, this is in radians. If I want to write it in degrees, then I want to get rid of radians, and I want to get degrees, so I put the 180 up here and the pi down here. In this case, so the radians cancel, and I have 180 pi degrees over 9 pi, and I get to cancel out the pi's. I could give you a radian measure that's like, 4.892 and not give you a multiple of pi, and then it kind of wouldn't cancel out. But the process is the same. 180 over 9 is 20, so 20 degrees is pi over 9 radians. It's not one of the ones we memorize, it's not on the unit circle, but it is one that kind of cleans up well. It doesn't have to clean up well. You can put it in the calculator and you could get 37.925 degrees, and that's fine. That's a fine upstanding measure of degrees. Give me my eraser thing. FYI, I'm waiting on a replacement. There we go. A replacement Mac that's been ordered. Okay, so that's the process. So that got you from a radian measure to a degree. Suppose that you were given degrees. So suppose you were given, say, 140 degrees, and you wanted it in radians. This time, the thing I want to cancel is degrees, and the thing I want to get is radians. So to make this one, I need to put the 180 down here and the pi up here. So degrees cancels this time, and I get 140 pi over 180. Cancel out the zeros. 14 over 18 is 7/9, 7 pi over 9. And now it's in radians. There's no reason for you to give me a decimal on this. There's a pi. I know what pi is. In fact, 7 pi over 9 tells me better where this lands in a circle, right? Because I would go 7/9 of the way to the 180 degree mark. So I could sketch this pretty well based on 7 pi over 9. So you just leave it like this. And it's radians, but you don't actually have to write radians. If for an angle you just write a number, you're implying that it's radians. If you want it degrees, you've got to put the degrees symbol. If you just write a number, it'll be assumed to be radians. Hopefully this helps you to understand how to get from one to the other, and that this is enough examples. My videos tend to run long and then people don't watch them, so I'm trying to kind of tighten this up. Let me know if this is okay.